All right, so the meeting's being recorded now. Here we go. So this week we are going to do two or three things. This week, normally we'd go out to the field and we would do a topographic survey. We don't get to do that, but you got some experience with the total stations the last couple weeks. And all we would do on our topographic survey is use one of those prisms like I was holding out in the field. And we'd be taking horizontal measurements, vertical measurements, and angular measurements. And I'll go over that in a moment. And we would use all of those points. We'd import them into AutoCAD, and we would draw our contour lines in order to create a topographic survey of a particular area. That's what we would do. And the way that we're going to do this in our digital space is that instead of going out, I'm going to give you a digital file with the survey data. You're going to have to take that raw data like you would if you were using a digital total station. Digital total stations, they generally give you data in just raw text format. So I'll give it to you in Excel format, so it won't be too terrible. But I'm going to give you that data. You're going to have to do a little bit of manipulation on that data to process it, and then input it into AutoCAD. And then once we're in AutoCAD, we're going to have to go through and create all the necessary parts of a survey. And I'll go over that here in a moment. First off, though, let's just check in on where we are at with our schedule. So let me just share my screen here. Okay, cool. So here we are, Lab 8, synchronous meeting on the 7th. Now, originally I had this module due in 2 weeks. Looking back at some of the previous classes, usually actually you'd be given 4 weeks to complete this assignment. So I have a handout that I will post after this recording with the updated due date, and I'll change that here in our schedule file in Canvas. But it is now going to be due on December 5th. That should give you plenty of time to play around with the data in Excel and do some of the AutoCAD. So after that, we have two final lab assignments. One of them is a GPS assignment. We're going to be doing this all online. And I think that this will be all asynchronous. So you're going to have to go through, watch some videos, fill out some quizzes, similar to what you've done in previous labs. And then Lab 10 is our county assignment. We'll be using the Santa Cruz County GIS information from the county in order to look up some information about a property in the area. And this is just a fun assignment. You get to kind of see how surveying, all those measurements you take in the field, how they're actually implemented, by a municipal government. So that'll be fun. And then we'll have a design project as well, and it'll be something that you can do, at home, and we'll be all good. Any questions about the schedule, what is left in the class, anything along those lines? Okay, well, if you do have anything, just drop it in the chat. I will answer it. Great. So before we get into the, So basically today what I'm going to do is I'm going to cover the Excel data that you're going to be given and what you need to do in AutoCAD. And we'll go through some AutoCAD basics, and that'll be our class today. So first off, just a quick question. Everyone can look, yeah, good. I'm still screen sharing, excellent. Now, in a topographic survey, is everybody comfortable with how we determine the elevation at a point if we're given the elevation of the benchmark and our vertical readings on our total station? Is everybody familiar with this slide that I'm showing, where I'm showing this equation, elevation 1 is equal to elevation benchmark plus V1 minus V benchmark? Thumbs up. And a couple thumbs up, excellent. So this is really one of the key equations that we're going to be using in processing our data. Yeah, so if you have any questions on that, please stick around afterwards, or we can set up any time, and I'm happy to walk through the math with anyone. But this is going to be the primary equation that we're going to be using in order to determine our elevations from our total station readings. So our total station readings, the benchmark, we're just going to take that once at the very beginning of our survey. We're going to, we're going to do a backsite to our benchmark, figure out that vertical distance, and then we're going to have our rod person take our prism, and we're going to walk around all of the important points, capturing all of our elevation changes, and that's just going to be this V1 or V2, V3, V4, so on. And we're going to be dealing, I think, with about 50 points. So that's going to be the main player here. So quick question to everyone. What measurements do I need to take with my total station in order to create a topographic survey?
You need to take horizontal measurements.
So horizontal, what kind of horizontal measurements?
That will be the distance from the rod bearer to the total station.
Yep. So we need to know the horizontal distances. What else?
Horizontal angles.
Horizontal angles. Yep. We want to know how, angularly in space where we are and how far away we are. So those two things are going to give us our horizontal control of our space. What else? Two more. Well, really one more, I guess.
Vertical angle.
Yeah, a couple of people trying to say it. And our vertical. Oh, sorry. Did you say vertical angle or vertical distance?
I said angle, but I'm not
Okay.
sure.
Well, vertical angle, we definitely, especially if we're using a total station where we're automatically recording all the information, it would definitely be a recording that was given to us. But remember the key piece of information that or the key equation that we're going to be using in order to calculate elevations is right here, shown in red. So we want to make sure that we get that vertical distance. But definitely as well, it's always good to have additional data. And that way, if there is any inconsistencies, you always have a little more data to go back and double check your calculations. So those are going to be the three important things. So let me pull up now the spreadsheet. Actually, let me pull up something else. So I'm going to give you a little virtual tour of our survey location. So here's Cabrillo College. Here's the STEM Center. And then I dropped a pin right here on the sidewalk next to the parking structure. And all of the data that we're going to be working with is going to be in this grassy zone between the parking center and, is that the gym? I can never remember. I wasn't much of a gym goer when I was ever.
That's Health and Wellness 1000. There's a gym inside of there.
Yeah, health and wellness. There we go. So it's a grassy area between health and wellness. So I've dropped a pin right here on the corner sidewalk. And in the data sheet that I will be providing to you, I give you the latitude and longitude of that point, which you can just throw into Google Maps in case you want an idea of the area. So this area, it's really nice with Google Maps these days. Let me see if I can. There we go. Google Maps kind of has a built-in 3D view. It's not perfect, but you kind of get an idea of some of the topography. Sloping down, makes sense, right? We're at Cabrillo, everything's rolling down the hill. So we have this walkway. Right where that pin is where the total station was set up. And the back site to our benchmark was actually taken over to the sidewalk. The sidewalk is actually an ADA accessible sidewalk. When things are ADA accessible, it generally means they have a good amount of surveying data associated with them. ADA ramps have to be constructed to a pretty tight tolerance. So those are pretty reliable points. So that's where we pulled the elevation, the benchmark elevation off of, was the sidewalk over here. Now, a couple other features about this zone. So it's pretty narrow and long. So we're going to expect all of our angular measurements to be pretty narrow, right? If we're surveying this length, our horizontal measurements, well, they're kind of constrained by the health and wellness building on, was it south? I don't know. It's on a bay. I can never figure it out. And the parking garage. So that's just a couple notes about the location. Like I said, I'm going to give you this specific pin in your data sheet. So in case you want to reference this in Google, please do that. A couple other notes just to make sure I have it in the recording in case you want to come back to this about this location is there's a retaining wall just about 5 feet back from the Health and Wellness Center. So a retaining wall is going to give us an immediate drop in elevation. So just keep that in mind as you're trying to interpret the data. There's a retaining wall right there. And of course, the walkway. Besides that, it's a few bushes and whatnot, but it's a pretty open, grassy location. So all of your data is going to be from this area. Any questions about the survey location? All right. Again, any questions, comments, feelings, throw them in the chat. I'll get to them. So that's where all the data is going to come from. And let's just have a quick check-in about north arrow on right. Oh, yeah. North arrow is over here. And my next point was actually going to be about north. Now, in how we're actually taking our measurements. So here's our pin. And I just told you that the benchmark was taken from over here by that yellow platform for the ADA ramp. And that was our 0 horizontal distance. So in AutoCAD, that's going to be 0 degrees. It's not north. So keep that in mind. But what we put into AutoCAD doesn't know anything about north, south, east, west. You have to, keep that in mind for your specific project, which is why I dropped that pin. So you can come back to this location. You can look at that little north arrow on the right, and then you can draw that into your AutoCAD drawing. Yeah, thanks, Kenny, for pointing that out. It's pretty important, especially since we're going to be using regular AutoCAD, not Civil 3D. I think this Civil 3D has a little bit more functionality. Excellent. So there we are in space, and that's our survey location. So let's now check out our data sheet. And I just asked you, what are the important values that we want to use, or we want to measure? So somebody mentioned horizontal distance. So in our C column right there is our horizontal distance, our horizontal angle in degrees, minutes, and seconds. That's how our total station reports it to us, and our vertical distance. Now, 2 constants that we have are the benchmark elevation, which is up here in cell C1, and that vertical elevation to the benchmark. These will be filled in with the exact correct values when I send it out to you. And in addition, you can see also in that first column right there is the latitude and longitude of the location. Just pop that into Google Maps and you'll have an idea of where you are in space. So what are you going to be given? You're going to be given all this information in rows 1 and 2, and you're going to be given all of the information, notes, vertical distance, horizontal distance, as well as the horizontal angle. And you'll be given that for all of the points in this survey. Now, I'm going to go over to AutoCAD for a moment before we get into our specific calculations. So we're going to just go over to AutoCAD, and we're going to walk through why we want to do things the way that we're going to do things. First off, AutoCAD is awesome. This is a side note, but I'm very excited about it. Here's some 3D drawings that I recently did in AutoCAD for a project that I'm working on. Not too complicated, just a little bit of threading, a couple angles, and I did some 3D work as well. Not really what AutoCAD's super designed for, but you can do it. So I had those, I had a few different parts I need made. 1, 2. So I had all these parts. I sent it to our machinist in Sacramento, and now you can see on my screen. Oh wait, can you see me, or can you only see my screen?
I can see you.
Okay, cool. So hopefully you can show the little part that I'm holding up. So I sent this to a machinist. Boom, they made it. AutoCAD is neat. It's a nice tool for. Here's the longer version of what I'm showing on the screen. So that's that. AutoCAD, good skill to learn. It's going to keep on coming back. We're just going to go over the basics as it's related to this lab. And I think that some of you have taken the AutoCAD class at Cabrillo. Some of you have a little bit of experience beforehand. So I'm going to go through the things that you need to know for this lab. If you are already an AutoCAD expert, and you are very comfortable with the program, you can, as long as you have all of the aspects that are required for the topographic survey, you do not have to do it this specific way. This is just some of the important points that you need to know for this lab. So first off, what are the different aspects that we need to show on our topographic survey?
Points and lines and some of the like bushes and walls around it.
Yeah, so features, environmental features, construction features, and you said you mentioned the contour lines.
Yes.
Yep, so major and minor contour lines. Then also, in addition to that, we'd like to have points, and we might want to have some text associated with those points. So in AutoCAD, the default thing when you open up the and we want to make sure those are all separate. You might want to have different line weights associated with different features. When you open up AutoCAD, you're automatically on the 0 layer. You don't want to do things on the 0 layer. You want to make layers specific to what you are drawing. So in order to do that, we're going to go to Layer Properties. And I've already made a few layers here. But really, it's as simple as clicking this little page sheet in the upper left-hand corner. It says New Layer. You click on it. You name it. In this case, let's call this walkways. Maybe I want a layer that just outlines the walkways. And when I do that, I want to give it a new color. The way that we're going to use AutoCAD is that we're going to actually assign different line weights based on the color in AutoCAD. So let's use magenta. That's pretty standard. So when you do this, you're going to do all your work in CAD. I want you to come in and make sure that all of your different aspects of your topo survey have their own layer. So at a minimum, that means that you need a layer for your major and minor contours, your points, and your text, as well as features. Does that make sense?
Yeah, for the most part, it does for me, but I'm not sure about everyone else. Oh yeah, good
Yeah.
question in the chat.
So
Well, there,
everything right now is being recorded. So you can go back and you can watch me do these specific steps. I mean, YouTube is an amazing resource for AutoCAD.
Oh my goodness, yes. Thanks for bringing
Yeah,
that up.
I mean, there's AutoCAD is such a huge program and huge company that there's almost like a sub industry of people that all they do is like AutoCAD tutorials. So you can learn some real fun things on there. So yeah, the main thing for layers is that it's under the Home tab in your ribbon, Layer Properties, and to create a new layer, you click that little stacked page icon with the orange dot, and it creates a new layer. And you assign that layer a new color. That's the main way that you create layers. So the next thing we want to do in AutoCAD, since this is a survey, and we're going to be putting in our points as horizontal distance and a horizontal angle. The command to do that in AutoCAD is point. So you can go down to this command bar at the bottom and just type point, and it automatically flashes a few different options. We just want the regular point. Press enter. Now it's going to ask me to specify a point. Well, how do I specify a horizontal distance and an angular measurement in AutoCAD? Well, I specify the distance, say 120. And what is the horizontal angle? Well, the way that AutoCAD accepts that information is that you use the less than sign, which is indicating an angular measurement. So 120 less than however many degrees our measurement was. So let's say that we had a 90-degree or 20-degree measurement. We're going to press enter. And did it show up somewhere? There it is. So sometimes you have to zoom out. You can see that a new point was created. But there's something wrong with this. Does anybody, not necessarily wrong, but it's something that is non-standard. Does anybody have an idea of what happened here? So here's our origin down here. So our origin is where our instrument is set up. So right at XY is where our instrument is set up.
So it seems like in our actual case, all these measurements are going to be negative because our instrument is set up in the upper left corner.
Exactly. Yeah, exactly. So as we have it now, all of the measurements would have to be negative, but that's not right. We know that when we're out in the field with our total station, we're turning angles to the right. So AutoCAD realizes that that happens, and they have some settings that we can change in order to accommodate that. So how do you change that? Well, we come down to our command bar, say units. So the first thing you're going to do is set up your layers. The next thing we're going to do is set up our units. And this dialog box will pop up of showing our length, our angle, and a few other things. Don't worry about any of the other boxes except for angle right now. So I was already playing around with AutoCAD, so I changed it to degrees, minutes, seconds. But it's also oftentimes oftentimes the default is decimal degrees. So just check that out. Go to degrees, minutes, seconds, and make sure your precision is to the seconds place, because our total stations go to the seconds place. Now, as Olga pointed out, we have an issue with the sign of our angle. So we're just going to check this box. It says clockwise. And another thing that you want to do is click on the direction box. And right now our base angle is to the east. Really, we want our base angle to the north.
What does it do?
What was that?
What does it do? What's that setting for? I don't quite understand.
Oh, yeah, no worries. I'll show you here in a moment. So normally what's happening is, as you saw from that previous measurement, it was 20 degrees from the x-axis. But we want to take angles from our y-axis to get associated northings and eastings. So now if I enter a point, so again, using the point command, and let's say 120 less than 20. So now our point is here. 20 degrees from our y-axis.
Okay, I think I got it right now. I think you just turned the whole setting like 90 degrees counterclockwise, the whole map, future map, right?
Yeah, so all those settings did is changing the base angle, as you said, 90 degrees. And then now by clicking that clockwise function, that is basically saying I'm turning angles to the right. So now I'm turning my angles clockwise off of the y-axis. So question, is there a way to make that point bolder? So there are ways to make the point bolder. Normally you don't change the boldness of your lines in this model space tab. You would just change the color. So let me put this on my points tab, which is frozen. So you'd have a different color. Now, if you want to make that point either a different style or bigger, yeah, or like with the crosshair. In this case, they are pretty small, right? Since we're over a really large area, I probably want to make those points bigger. The way that I make them bigger, and there's a couple different ways of doing this, the way that I've found works pretty well is if you type in EDP type, and you get this dialog box with all these different point styles, and you can also change the point size, and you can set the size relative to the screen. So what that does is it automatically adjusts the size of those crosshairs as you zoom in and out. You want to do this or else it's going to be, yeah, there we go. And sometimes if you zoom in too far, they won't readjust. So your points don't readjust, that's fine. Just type in that DDP type again and just say okay, and they'll automatically readjust. Sometimes AutoCAD does not automatically update very well. That's all right. So, does anyone, if you had, let's say, 50 points, and every single point, I have to type point, I have to type, actually, before I get there, one more thing, one final AutoCAD weird thing. So AutoCAD eventually what we're going to do is that we're going to take all of these points that we create in this model space tab, and we're going to want them to print them out. So you print things out in AutoCAD by coming over to layout. I've already made this adjustment in my default, but we're gonna want these topos on 11 by 17 pages, and when you print them out to PDF, so you just print to PDF, they'll come out as 11 by 17, which changes the aspect ratio and it makes it a lot easier to see. But the auto default for AutoCAD is 8.5 by 11. So how do we change that? Well, we come over to this layout tab, click on that. Over in layout on the left-hand side, we click page layout. Now, if I'm on, just take a look down at the bottom of what tab you're on. Right now we're on layout 1. Awesome. We're gonna wanna, and you can see here under page setup manager, layout 1 is highlighted. So we're just gonna modify that. And in this second or third box here, paper size. So right now it's 17 by 11, but some of you might wanna actually do it as 11 by 17 in portrait. So it's up to you whether or not you present this in portrait or landscape, but it does need to be 11 by 17. And that's how you change to 11 by 17. And then just press OK. And then you can close. And then if you can see there that my screen auto adjusted, just implementing those changes, although nothing really changed because I already set my paper to 11 by 17. So I guess one last thing about when you're in layout space, this is the physical piece of paper here, right? So this is representing real physical world space. But everything inside this viewport is our model. So you can see them kind of dragging this around. But I'm working in paper space. Now, what I want to do is, once I get all of my points set, I'm going to double click in my viewport, and I need to choose a scale. Now, this is a weird thing about AutoCAD, especially if you don't have Civil 3D. It's really designed for mechanical drawings, but we can kind of make it work. But does everybody understand? Have an idea of how scales work? That they are giving us a conversion from paper to real. So the left-hand number that's shown here is the dimension in paper space, and the right-hand number is giving us the dimension in real space. Yeah. So you can, yeah, as Kenny pointed out, you can get the those dimensions in percentages. I'm not a huge percentage person, but yeah. So what we're going to do is in AutoCAD, 1 to 30 is saying for every 1 inch on paper, that's 30 inches in the real world. But does that make sense for civil engineering applications? Especially something as large as the Topo survey? Not really, does it? We're dealing with you know, tens, hundreds, thousands of feet. So we're going to need to do a little trick in order to get an appropriate scale. And there are some other scales down here that are inches to feet. Those are mostly all mechanical or architectural. So don't worry about those. We're going to make our own. So we're going to go, what? Oh, for some reason it doesn't like what I just did. So if you ever have any issues in AutoCAD, click in your space that you're working in, press the escape button a bunch of times. That usually clears things up. So let's try again. Let's go to custom. Excellent. So here we are. Edit drawing scales. Now, what are some acceptable scales that we can use on a drawing? We all have our engineering scales, right? So what are the scales that we have available to us with our physical engineering scale? Cool. Yeah, 10, 20, 30, 40, 50, and 60. Some engineering skills have like 25. That's not super common. But yeah, 10 to 60. So in order to create that scale in AutoCAD, we're going to say add, name the scale. So let's make one for 1 inch. And remember, left-hand side is paper space. 1 inch is equal to 40 feet. Now, our paper unit is 1. And our drawing unit, or our real unit, needs to be in the same units as the paper units. So if we want to go from 1 inch to 40 feet, what does that look like? I'm going to stop sharing here. I'm going to pull up my iPad and we can go through the math. All right, let's just do the math really quick. It's nice to see how it all pans out. So 1 inch. I say 40. We're doing 40, right? Is equal to 40 feet. But in AutoCAD, we need the units here and the units here to be equal. No problem, we can do that. So we want to keep our paper units the same, right? Because we can't change the size of our paper to, oh, they stopped sharing? Can you still see what I'm doing?
We see the 1 inch equals 40 feet, and that's it.
Oh, huh. I guess I stopped sharing for some reason. Sorry, everyone. Okay, so my iPad for some reason can't connect. That's fine. You saw the 1 inch is equal to 40 feet. So the upshot is, how do we convert from 40 feet to an equivalent number of inches? What's the conversion factor?
Times 12.
So yeah, it's gonna be times 12. Does that make sense, everyone? To some degree? Whoa. Sorry, I just lost my screen again. Okay. I can't see the chat right now, so if anyone's dropping anything in the chat, I'm sorry. I'll pull that up here in a second, but let's just get through this last little part of adding different scales. So 1 inch on paper is 40 times 12 units in real life. So what are our drawing units? What's 40 times 12?
480.
480. Not more. Yeah, 480. Okay, 1 second. I'm having some technical difficulties. Please stand by for 60 seconds. All right, cool. Sorry about that, everyone. So yep, that's it. You just have to multiply whatever your value in feet is by 12 to get the value in inches. And then it'll show up, say, okay, okay. And now here at the bottom, we can open up our tab and we can have the appropriate scale. So you might want to make one of these for 30 feet, 1 to 40, and all the ones between 10 and 60. And you'll just have to play with these to figure out which works best for your project. Awesome. Any other questions? Oh, I guess the last thing on this page would be you also need to have a title block. That's as simple as having a little block at the bottom with your name, who checked the drawing, the date, and the scale that it was drawn at. So another thing you would absolutely have to add here is the scale. And that would be your paper space drawing. So,
Kyle?
yeah.
Real quick, the picture looks a little small. I think what's happening is our scale is based on 1 unit being 1 inch, but in the drawing, we're using 1 foot for the unit. So
Exactly. So I feel like you're always just like 15 seconds ahead of my own brain, Kenny.
Thanks.
So Kenny read my mind. So the thing I was gonna come back and say is that when we enter these points in, we can't enter in the vertical distance or horizontal distance in feet. We need to convert it to inches. So all of this is driving home at the fact that it's going to be really annoying to have to input line by line, multiplying by 12 every single time in your calculator, every single point. So let's say let's say I had point number 1, vertical distance, feet, really things were on our horizontal distance and the degrees. So horizontal distance is 20 feet and the angular measurement is 10 degrees, let's say. Well, okay, if I input a point, enter my point command, well, the distance is 10 feet. Okay, multiply that by 12, that's 120. Well, that's nice because it was exactly 10 feet, so I can do that in my head. What if it was 10.57 feet? Well, then I have to pull up my calculator, figure that out, and I would also have to put in 10 degrees, 15 minutes, and how many seconds was it? 20 seconds. And 20 seconds. Well, and there we go. I have my point. But you can imagine that's going to get really, really tedious, especially since the next thing that I have to do is that I have to label this point with the elevation. Okay, my elevation at that point was 209. So, okay, how do I do that? I come in, text, click on that point. Oops. I draw a text box. Okay, now I enter my text, 209.12 feet. And then, okay, it's too small. I have to click on it. Okay, I put it on my, let's see, I have to put it on my tab. What I'm getting at here is that this is going to get really, really tedious. Does everybody agree? Thumbs up. Yeah.
Yeah, I definitely agree. It reminds me in Engineering 25, we had a design project that we had to do. It was much the same thing. We had multiple objects to put down and then had to go through
Yeah.
manually stuff in.
It's a very tedious process, especially since, as I mentioned, most equipment is going to be digital, and it's just gonna spit out to you in raw format. So it probably wouldn't get it. It wouldn't come in Excel format. It'd probably come in a text file, but you could import it to Excel very easily. You're just going to be given the vertical distance, horizontal distance, and the degrees, minutes, seconds. You'll be given these 5 values. Well, maybe there's a better way. Cliffhanger, there is a better way, and it's going to be super cool. And I'm really excited about it because when I took this class, I tried to kind of figure this out. And now that I'm taking this class, I figured it out. And I think that I've condensed it into a really nice, like really straightforward form. It's 11 o'clock. I'm going to stop this recording. So that's kind of all the intro to AutoCAD stuff. Keep in mind, we will have, you have 4 weeks to do this assignment. And I will be having office hours every week. So please start on it sooner rather than later. And then you can come to my office hours and we can go through all of the things. But for now, let's as we go from one topic to the next, let's stop this recording.